Today, we're finally going to talk about TIG Aesthetics back purge plugs. If you've ever heard before, oh, that's for back purge, you're in the right place. I'm going to walk you through how these work, what you need to run this system in your shop, and why this product is designed the way that it is. Whether you're in the motorsports, aerospace, or any other industry where clean welds matter. These are purge plugs. These allow you to block off the tube that you're welding on so you can fill the part up with argon. Everybody knows it's what's on the inside that really counts, so using this allows you to have that clean weld inside and out. We use a high temperature silicone. This is rated to 600 degrees Fahrenheit, and that translates to me being able to weld about 1 inch away from them without actually causing damage, and that's on this thin wall tubing. You know, the thicker the application, the more heat and amperage, the more space you're going to need from your parts, but it's very surprising to a lot of folks that we can weld this close to a silicone purge plug. Inside, we include a multi-layer screen diffuser to help reduce turbulence and create laminar flow inside the parts that you're welding. This reduces purge wait times, flow rates, and increases quality of the outcome of the weld. So now that you've seen the purge plugs, the next part you're going to need is a argon regulator and an argon source. To keep it simple, I like to use these dual flow meters. This is the cheapo one on Amazon. I don't have an exact brand for it. This is a very entry-level dual flow regulator. These come standard with a 1/4 inch hose barbs on them, which is exactly why I offer this simple 1/4 inch silicone tube that's nice and flexible. It just slides right onto the part. And you'll see the other side, I've changed the fittings to a quick disconnect fitting. This is all stuff that comes in our QD hose kit, shower heads, hoses, as well as the fittings to connect to your regulator, making it very simple, very easy to use. You're not going to pull that off. This one you can pull off. So be careful if you're running a 1/4 inch hose or the 6mm tube. These little shower head fittings are an upgrade that I recommend. Let me show you why. I created this product to further diffuse the gas by adding this 90-degree turn in the flow. And you'll see once you pop this into the plug, that it diffuses below the screen that goes in above this, and that's exactly how you stabilize the flow inside of a part to purge them out as efficiently and fast as possible. We're proud to work with a variety of industries, from motorsports to aviation, aerospace, and defense. They work with materials like titanium, Inconel 625, which is very common in aerospace, as well as other nickel alloys. More on that later. But in my shop, I like to work on automotive stuff. And right now I have a very critical stainless part in the shop. I had to bore some holes in these turbine housings to allow for a bypass valve to go on there. So we're going to weld these out to show you how well these purge plugs work on a very critical item like this. So let's go ahead and start our fill plug at the bottom. I'm running that 2 inch. This is more like 2 1/4. Fitting that at the very top. I'm going to put a plugged 3 inch on this center section flange. Perfect fit. I'm going to put a vented 3 inch on the housing outlet. We're going to jam it in there really good. And our last part is going to be our 1.5 inch schedule. It's for our 44mm 44mm wastegate outlet. The process for this is going fill from the red plug, keep the red plug below the joint, keep my vent out of the blue plug. Once I start my gas up, I'm going to let this vent in the middle for a second. Once this part fills up all the way, I'll be able to plug that and get to welding. About 45 seconds later, we're striking up our arc to make our root pass. Always be sure you have your piece tacked on really good before you start putting a lot of heat in as well. Just a beginner tip. Running about 100 amps, putting as small a filler rod as I can get into this. Just trying to ensure a nice deep, well-penetrated root pass here. And of course, we're going to cool this whole part to ambient. There's a lot of steel in this little chunk. It is heavy and dense. I'm going to keep it cool. So wire brush after it's cooled off, and we're going to run our cover pass over top. Pulse welding. Sticking filler rod in there as much as I can. This is like 1.1 pulses per second, about 150 amps on the peak. So I'm able to cruise through and make these look pretty darn good. Man, that's got some cool color in it. So let's talk about this user-driven design. When I created this product, I did so because I just couldn't find a solution that I was happy with on the market. You either had to tape parts up, or you had to, jam a big hunk of aluminum in there, or something else that just none of them worked right. So I had the idea of making a purge plug that was soft, reusable, didn't have to be super heat resistant, something that consistently did the same job, shaving tons of time off the part, and just doing a better job putting the purge into the piece you're welding. Every plug is shaped, vented, and built based on real-world welding problems that I've come across in my shop. Come to find out, this problem wasn't just mine. It turns out I'm selling these parts to guys who build cool exhaust systems in their garage. I'm selling these parts to these tools to manufacturing facilities that build and supply some of the largest rocket companies on the planet, defense contracting. We service nuclear cooling systems, are often made out of titanium and nuclear. So these guys are welding a lot of those parts because it's such a reactive, corrosive process. And that's a quick look at TIG Aesthetics back purge plugs. If you're looking to make cleaner, stronger, faster welds, these right here are a game changer. I'll leave the link in the description below. And if you've got any purge tips you want to share with everybody, you think I welded these parts right or wrong, you think the welds are going to break, comment below and I guess we'll find out.